Hello, I'm Luca di Persio. I'm the scientific coordinator of the new master degree in data science at the University of Verona. And today it's my great pleasure to introduce you Professor Alberto Castellini and Professor Alessandro Farinelli. They both belong to the computer science department at the University of Verona, and they in fact collaborate with respect to teams related to artificial intelligence, multi-agent systems, and application of machine learning and neural networks tools. In particular, Alessandro Farinelli will teach the statistical learning course that will be provided during the second semester of the first year of the new master degree in data science. And if, as I hope, you will join us in this challenging adventure in data science, you will learn by him a lot of interesting tools related to machine learning and neural networks used to solve concrete problems that happen with respect to real case studies. In particular, with respect to this latter aspect, I strongly suggest you to watch very carefully the video till its end, because at the end of the video, Professor Alberto Castellini will show you a very interesting real life case study. And so I'm really convinced that you will enjoy a lot his presentation, and also the presentation of Professor Alessandro Farinelli. So hope you will enjoy their video, and that's all for us with respect to my presentation. Enjoy.
Welcome everyone, my name is Alessandro Farinelli, and with us today we have also Alberto Castellini.
Hi everyone.
I am a professor at the Computer Science Department of the University of Verona, and I'm the teacher of the course on Statistical Learning in the Master's degree in Data Science. And in this short video, I would like to give you a brief overview of this course. My main expertise is on artificial intelligence techniques and statistical machine learning methods to analyze data. And particularly in this broad area, we focus on data that comes from sensors. This is a very interesting application areas, as there is a growing number of sensors that we can use to collect information. So you can consider, for example, sensors that collect measurements about quality of air, quality of water, or sensors that collect information about the status of machines in industrial environments. And clearly, analyzing this data is very important, because these sensors can give you key information on the situation of the world, such as, for example, whether a machine is not working correctly. But with the growing number of sensors, analyzing all this data by looking at them with a human user looking at the data is impossible. So it's very important to have computational techniques that are able to extract information from data. And this is exactly what this course is about. This course will give you an in-depth overview of the main statistical machine learning methods that can be used to analyze data and extract information from this data. In particular, we will focus on the mathematical foundations of these techniques and how these tools are actually used every day by data scientists. But we will also see hands-on exercises, and there will be specific laboratory sessions that will allow you to actually apply all these techniques, all the techniques that we will see, on real problems, so that you can have a clear idea of how these techniques can be used and which kind of problems can be addressed and solved by these techniques. To give you a clear example of which kind of problems can be addressed with this technique, I leave the word to Alberto Castellini.
Hi everyone, my name is Alberto Castellini. I work at the Computer Science Department of the University of Verona. And today I will show you a very interesting from my point of view problem that we solved recently, and in this problem we used methods of data analysis, machine learning, and artificial intelligence that are the topic of my research. Okay, so the problem was to predict the heating load in the next 48 hours of a district heating network, which is a network like this that you can see here in this picture. A power plant produces heat which is distributed to buildings, and of course the amount of heat to distribute depends on weather factors like the weather, the temperature or the environment, but also social factors like holidays and other factors. And what we did was actually to acquire some data, okay, and to produce some models from this data. In this particular case, we developed some auto-regressive models, and we use this model to predict future heating loads, okay. So you can see here in this slide that some of these predictions of our model was very precise. The blue line here is the real load required, and the red one is our prediction. So in this case, the prediction is very good, but in other cases in which we have some uncertainty about the behavior, basically, of the people or the weather factors, the prediction could have some more error. Okay, so the goal of this work was basically to identify the best variables, the best factors, in order to improve our prediction. Like in this case, we saw that on Easter we made some errors, and then we understood that adding a variable related to holidays made a good improvement of our model. So I think this kind of analyses are very interesting, and they allow you to learn a lot of things about the real world. So I hope to see you in the next year here at the University of Verona for this course. Bye, everybody.
Thank you very much, Alberto, for the interesting explanation. And as Alberto said, we really hope to see you in class in the next semester, and we hope that this video gave you a good overview of what you will be seeing during the course. Thank you very much.
Bye.